Assalamualaikum, my name is Muhammad Muizzuddin and I want to explain the abstract or the project summary for this project. This project designs a power supply circuit for a 9V and negative 9V converting AC to DC using multimeter simulation. It ensures effective voltage smoothing and explore eco-friendly components, energy harvesting and switch capacitor regulators. This strategy prioritizes safety testing and a cost-benefit analysis for affordability, efficiency and environmental impact on electronic sustainability.
Okay, the project aims to design and test a power supply circuit that can convert the AC voltage to the DC voltage, which can be used to power various electronic appliances and equipment. The power supply circuit consists of a transformer, diode and electronic capacitor, and the three terminals for the positive and negative IC voltage regulator. The circuit is designed to provide a stable DC voltage of the positive 9 voltage and the negative 9 voltage, which can be used to power electronic component and pipe. The project will involve using the multi-sim simulation software to validate the functionality of the complete power supply circuit and measure the performance of the circuit using the voltage and current measurement. By providing enough information to generate interest and support while avoiding the unnecessary detail. The project description should also align with the organization's strategic goal and objective, demonstrating how the project will add the value and contribute to the organization's success. Project methodology: ensure that the power supply circuit function as expected and provide a stable DC voltage that can be used to power electronic applications that involve the design must include the transformers, diode, electric capacitor and the IC voltage regulator. The circuit will be simulated using the multi-sim software to identify any design issue, while the data analysis will be performed by comparing measured data with the expert value and identify descriptions. Theoretical development will support the measured data by calculating the expert voltage and current value based on the circuit design. Performance measurement will be done using the voltage and current measurement at the various points in the circuit. So the report will be written to document project finding or include the all element above and review and reserve as necessary. And the design circuit may also reserve based on the project.
Hai, Assalamualaikum warahmatullahi wabarakatuh. My name is Aifah Hanim binti Zanizam and I will explain about the selection and justification of the simulation component value. Firstly, for the transformer, which is T1, boasts a turn ratio of 10 to 1 to 1, effectively stepping down to the 240 VRMS AC input to a safer and regulated 24 VRMS output. Next, for our voltage regulator, LM7809CT and LM7909CT were selected to provide positive 9 voltage and negative 9 voltage output, indicating the necessity for dual polarity regulated voltage in our circuit. For full wave rectification of the AC input voltage, we've opted for the 1N4002G diodes. Capacitor, including large one, which is C1, C2, C5 and C6. For reservoir purpose on smaller ones, C3, C4, C7, C8 for high frequency noise filtering. Ensure a stable output before regulation. And we also use multimeter, which is XMM1 and XMM2 to measure the voltage for the circuit.
Okay, so for the stimulation circuit, channel A showcases a positive half-wave rectified sine wave with a peak voltage of 16.4 volts. The diodes clipped the negative half as anticipated, while channel B displayed a smoothed version of the rectified waveform, with the capacitor filtering out the AC component, resulting in a relatively constant DC voltage with a 15% ripple. Okay, now considering multimeter readings at 9 volt and negative 9 volt. At 9 volt, the positive half wave aligns with the rectified sine wave, consistent with the peak voltage. Interestingly, at negative 9 volt, due to the rectification, the multimeter would still register a positive reading. This is because the diodes prevent the negative portion of the input sine wave, resulting in a rectified positive voltage. The time-based setting at 10 milliseconds indicated a 200 millisecond simulation. In summary, the circuit effectively converts AC input into DC with observable ripple, and adjusting capacitor size or adding filtering stage can further. Okay, the functionality of this simulation circuit is rooted in its conversion of a 240 VRMS AC input into a dependable and smooth dual DC output of 9 volt and negative 9 volt. The process initiates with a primary winding transformer that steps down the voltage, followed by a bridge rectifier circuit converting AC to pulsating DC. This pulsating DC undergoes filtration through capacitors, which is C1 and C5, resulting in a stable DC voltage. The two voltage regulators plays an important role in ensuring fixed and reliable output voltage. The comprehensive measurements, including a 24 VRMS step-down, 339 volt peak-to-peak pulsating DC, and minimal voltage ripple, attest to the circuit's proficiency in delivering a stable power supply. In conclusion, the circuit functionality position its powerful solution for various electronic applications requiring precise and regulated DC power. Its systematic approach to voltage conversion and regulation, coupled with the minimal ripple across output capacitors, makes it an ideal choice for powering sensitive electronic devices where consistency and reliability are important. Thank you.
Assalamualaikum and hi everyone. My name is Narjana Zatibeteza. Today I want to present three elements from discussion and analysis. First is creative solution proposed. First, switched a capacitor voltage regulator. Switched mode power supply outperform linear regulator, particularly under high currents or input voltage. This system utilizes switching transistor for output voltage regulation, minimizing power dissipation as heat. Second is energy harvesting, designing power supply for energy harvesting from environmental sources like solar, thermal, or piezoelectric element offer an eco-friendly alternative to traditional grid power, contributing to a reduced environmental impact. The second element is advantage and disadvantage of the proposed solution. For the first, switcher capacitor voltage regulator, for advantage is higher efficiency, smaller size, and lower heat dissipation, and the disadvantage is more complex design and increased EMI. For energy harvesting, its advantage is that power device in remote location and reduce reliance on batteries, and disadvantage is low output power and requires specific energy sources. The three element is eco-friendly, component, and sustainability assessment. First, gallium nitride transistor. These transistors have lower switching losses than traditional silicon transistor. which can improve efficiency and reduce heat dissipation. Second is silicon carbide diode. This diode have higher voltage and temperature rating than silicon diode, which can improve reliability and reduce the need for heat sink. The last one, biodegradable capacitor. These capacitors are made from naturally derived material and can decompose at the end of their life cycle, reduce electric waste. That's all for me. Thank you.
Hi, my name is Farzalika Aslam. Now I'm going to explain about the discussion and analysis. End-of-life considerations are important for electronic circuit disassembly, and recycling is important for environmental sustainability. It requires the use of appropriate tools to isolate parts such as resistors, capacitor, diode, and transistors. After the material is taken to the recycling facility, the metallic and non-metallic components are separated separately. The implementation strategy involves creating and testing circuits, including construction, setup, component assembly, soldering techniques, safety measures, and quality assurance. Proper operation and safety are ensured by testing under various loads and securely fastening connections. Last but not least, a cost-benefit analysis. The recommended design offers environmental sustainability, affordability, adaptability, control manufacturing, and efficiency. It converts AC electricity to DC voltage with minimal power loss, requires careful assembly and testing, and can be recycled and adapted. That's all for me. Thank you.
In conclusion, this project successfully explored efficiency AC to DC conversion in power supply circuit design, proposing innovative solution for a 9V and negative 9V power supply while prioritizing safety and sustainability. The integration of eco-friendly components aligns with the contemporary design practice, contributing valuable insight to the field.